Hi, good afternoon, everybody. Tony here with Wavecom Technology, and it looks like we're about ready to start. I'm going to introduce a colleague in the industry, professional, really outstanding friend of Wacom. His name is Joe Shoopak. Joe is former background is director of art with Sony Online Entertainment, and now working with AI here in San Diego and Coleman University in the game development industry as well. Joe?
Thanks, Tony. Could you do me a favor? Could you?
Sure.
Is there water out there that I could grab? In case my throat dries up. Hi, everybody. Happy to be here to talk to you about game design and the industry. Let me just take a quick survey, if you don't mind. So, how many people are actively involved in a game development program? It's about half the folks. Okay, cool. At high school or college level?
High school.
High school? Okay. All right, well, a little bit, I made this presentation for kind of a general audience. There may be some things that people in a program may be familiar with already, maybe not, and especially thank you for those folks that are interested in some of the basics. I have some of that in here too. Like Tony said, is this working, by the way, or is?
Well, that's for the camera.
Oh, it's for the camera. All right.
Okay.
As Tony mentioned, currently I'm an adjunct professor at Art Institute of San Diego, Art Institute of California, San Diego, where I teach game development. I've taught portfolio prep classes there. I teach a series of 3 courses. The first one starts with pre-production, 11 weeks long, and then 2 11-week classes where students create their own functional game. So I do that at Art Institute, and I also teach at Coleman University game development and design in their capstone program. It's very similar to the program at Art Institute, but it's much more throw people in the water and see how fast they sink or swim. They develop their whole game from a previous game design document in 10 weeks. So they're usually more abbreviated, simple mechanic games that we do at Coleman. Previous to that, my longest stint in the game development industry, and I've been in game development since Atari 2600 days up until 2015. So I've worked on games for the Atari, for the Sega Genesis, PlayStation 2, 1, 2, 3, and 4, and a lot of PC games for Sony Online Entertainment. Sony Online, I was there till 2015. They were sold and renamed Daybreak Games, so they're still in existence, and a lot of these games are still going. At Sony Online Entertainment, we did massively multiplayer online games, which I don't know how many of you are familiar with the term MMO, but they're designed to be played by thousands of players simultaneously, and they have live content, so we're always creating on very short time scope additional live content to drop to users. So how I got, they asked me to give you a little bit of background about how I got into game development. Since I'm a really old guy, probably older than most of you, maybe there's a few older guys than me here, I don't know, but there was no game industry when I came out of college. I was educated in the traditional arts as a commercial illustrator, and I learned game design on the job. First job was in educational software for education systems, which eventually became Jostens Learning. Then from there, Blue Sky Software, which was a San Diego company that did Atari and Sega Genesis games. So there were no high school or college opportunities to learn the craft. I learned as the industry grew, I grew with the industry. So I grew up in the arcade era. I don't know if anybody remembers Computer Space. It was the first commercially available coin operated video game. And in like middle school, early junior high, I played a ton of arcade games. Played a lot of Dungeons and Dragons. Enjoyed fantasy and sci-fi literature. There were just really no job opportunities for other than computer programmers to do that type of work. So I grew up with I keep hitting the wrong button. I grew up with the first generation game consoles. I don't know if anybody here had any of these, but the first one I owned was Pong, which my grandfather got me in Christmas of '75 from Sears. And my sisters and I played that game constantly. My father kept making us shut it off because he was afraid the elements would burn into the TV screen. So we could only play for like 15-minute sections when he was home. When he left, we played longer. But whenever he saw us playing it, he would say, "Okay, you're done." So, and that kind of fueled my passion for, playing games, although I didn't really understand until after I graduated as an illustrator that could even be a viable career. And currently, we're in the 8th generation of game consoles, about to go on the 9th generation. 2013, where we saw the last large release from the 3 big companies of their latest software. So we're headed into the 9th very soon. You guys play a lot of games? Yeah? When you can? Okay, good. So I want to talk first about what the current career opportunities are. And I'll separate them into 3 major categories: designer, programmer, and artist. There are other categories like audio, web development, customer service, things like that relate to video games. The production and management side, which I'm not really going to touch on here because they tend not to be an entry-level path. It's something that you typically grow into once you've been in the industry for a while. So in focusing the conversation about what are most students who come through college, what pathways are they going to, where their entry point's going to be, that's what I'm going to kind of focus on today. So we'll start with game designer. And there are a lot of different sub-disciplines under designer. I'm not going to name all of them, but I'll hit the major ones here. The first is content designers. This is often what people think of, especially students, when they think about being a designer. Oh, I get to write the story, I get to write the dialogue, I get to come up with the story arc and write out what all the cool characters are. It's definitely very attractive sounding job. It's only one of the many design jobs that are available. Systems designer. This is a large subcomponent of the designer, and they deal with the in-game systems. I listed a couple here, like avatar creation. You got into a game where you have to create an avatar, you get your choice between different races, different hairstyles, you can choose different classes and abilities. All that has to be designed. Itemization designer, that's somebody who will take all the, for example, wearable pieces you can wear in game, and all those have to be itemized. They all have, some of them will have different advantages and disadvantages in different, like +7 versus fire, -6 versus ice. They'll have different economy costs, and that is definitely tied in with the game economy. So there are designers that work completely in that area to keep all those things balanced. So when you get that cool broadsword at level 20, it's appropriate to level 20, it does appropriate damage to enemies you're fighting, and it sells at some appropriate price back on the marketplace. And it's a very complex balancing job. Level designers are one of the probably the more common design paths for entry-level folks. Level designers typically take assets that have been created by the art team. And generally, the art team is working with the design team on designing those assets, but if there's I'll give you an example, there's a mountain village that has to be designed. A level designer can work with an artist to design that landscape and then actually take the housing elements and the roads and place them to make an attractive path that goes through and that directs you to appropriate quest points. We'll also design what NPCs or non-player characters live there, how they interact with players. So it's when we did MMOs, it was very common for we would do 10 or 12 different zones, and each game designer would be in charge of one or two of those zones, populating them and making sure all the quests were written and balanced appropriately. Technical designers, kind of part programmer, part designer, in charge of actually implementing the gameplay and making sure it's functional. And usability designers, UI, user interface, making sure that everything that the player or user needs to know is displayed in a clear, understandable way on screen. And usability also incorporates UX, or the user experience. And this also dovetails with analytics, programming and analytics, because what we do, especially on the MMO side, and well, really any console game that has an internet component to it, which is pretty much everything now, when you play a game, the developer can pull that data out and knows exactly what you're doing at any different time. And they'll deliver a wall of data to a usability designer that will show that, hey, when people went into this area, 75% of the people logged out at this point. So there's clearly some frustration element here, and then the designer will go in and try to figure out what it is. Or on this quest line, 90% of the people made it to this point, and then only 40% went beyond. And that usability also outside the game, with our own website development, usability designers were important as well too. We had one that was really interesting. We had a kids game called Free Realms. Anybody hear of Free Realms? It was out for a couple years. And on the usability side, when people went through the EULA or the registration process, we found out that we were losing like 70% of the initial registrants at one point, and that was entering the birth date. And after doing some research, we realized that most of the users are under 13. They knew how old they were, but they didn't know what year they were born. So when they presented with, when were you born? Oh, April 7th, and a slider that goes 1900 through 2000, we had a lot of like 100 plus year old people apparently playing the game, because they would just click whatever was on there. So, or they would just at that point just say, I don't know, and move on to something else. So the usability designer is important there. And in that case, there was real monetary gain from figuring out how that usability flow wasn't working. So the one additional role here that I'm putting under game designer, although technically it's not a game design job, is tester. And all games, go through robust testing, both internal and then beta testing to when they open up to outside players. And In my experience at Sony Online, probably about 70% of our designers got their start as game testers. The reason being that game testers are assigned to go through the combat and itemization systems and look for things that are broken, or go through the quest lines and figure out what's not making sense. And so by virtue of that, when the design team needs another designer, they often first go to somebody from the test department who already knows all the systems inside and out, rather than going outside and trying to teach somebody. So tester is a very viable pathway to game design. So second broad category here is game programmers. They deal with creating the actual game engine. There's a lot of commercial game engines that are available now. A couple I talk about a little bit later. Larger companies, Sony Online had their own engine that they created from scratch. And the game engine itself, and all the subcomponents of that, like the physics engine, the graphics engine, some of those are delivered via middleware now, pre-existing physics packages that you can integrate into your engine, but that integration still needs to be done. Gameplay programmer, similar to what I mentioned with on the design side, is responsible for making sure all the gameplay works the way it's supposed to work. Artificial intelligence is a very growing sub-role of game programmer, especially for large open world games. Probably 10 years ago, when you played an MMO or an adventure game, the non-player characters were not incredibly smart. They had maybe a couple little factors that they considered. They usually had some path they would patrol. They would have a radius at which they could see you and they would attack you. And maybe they had some simple flee code so that when they dropped under so many hit points, they would try to retreat. So artificial intelligence for games is becoming more and more realistic, and I think this is going to be a really burgeoning field. One of the last games I worked on there, we had NPCs or non-player characters that would decide how they would attack in groups. Their responses would be based on what a leader did. You could gain faction with them. So if you successfully attacked these non-player characters a number of times, they would have a different reaction to you than the first time they encountered you, and can get very sophisticated. They could team up with other non-player characters to attack a player character. And all of this is aimed at where games are going, is to try to simulate a very realistic experience and bring you in and immerse you in that world. And when player characters are not behaving in a realistic way, it kind of takes you out of it, and you see them as just little widgets you're trying to get by. So artificial intelligence is a very growing discipline. Network programmers that deal with all the issues with delivering a game over a network, packet loss between servers and clients, making sure that people at different locations are seeing the same thing on their screen. So when I'm playing here in San Diego and somebody's in New York, and we're playing against each other or with each other, we're seeing the same thing on our local clients. User interface programmers take that actual design and artwork that's created and do the actual guts programming of it. Tools programmers, they work with artists to create some tools that help not only artists but designers create content for the game. A tools programmer might write a tool that allows a game designer to write quests. So he might basically create that programming template that balances some of that game function for the designer. So if he's has a certain number of creatures you're fighting, it'll calculate that level based on the level of the person fighting, and those kind of tools will help a designer create a balanced piece of content. Sound, it's kind of a separate job, but it does relate to programming as well. And then I want to talk about game art pathways, which is my primary experience. So as I talk about tools, the tools I talk about are going to be related to game art. So the main opportunities for game art I would divide into concept art, modeling, which is creating the 3D assets for the game, texturing or surfacing, painting the 3D assets so they look realistic, either creating those procedural textures or actual 2D program painting that's then projected on a 3D model. Rigging, which is preparatory to animation. So a rig is a skeleton that is created that will drive a character. And that rigged skeleton will have bones and connections and rotational data, forward kinematics, inverse kinematics that inform the way it moves. So then when you bind a mesh to it, that is a puppetry setup that an animator can take and then start to manipulate. So rigging is really a whole class in itself, is making that kind of puppetry underlying framework that the animator is going to take and manipulate. And everybody pretty much knows what animation is. Effects, spell effects, fire, smoke, weather effects, these type of things that you encounter in game that are not physical assets but procedurally generated effects. The actual user interface art. And the technical artist, who, like I mentioned on the code side, a technical artist is part programmer, part artist. They understand the art workflow, and they create scripts that help artists do their work more efficiently. Quick example, a game has several different body shapes of characters. It has a big hulking orc and a regular sized human, a very thin elf character. You can design wearables and weapons that fit on the human character. You can actually change the position of all the vertices to make that fit on a larger character. You can do that each time by hand, or a technical artist can figure out where all those positions are changing, make a tool, so with the press of a button, when you create something for a human, it'll automatically scale it and fit it to the different characters. So a technical artist can put in like several weeks of work and save hundreds and hundreds of hours for a modeling artist by making those efficient tools. So the thing to remember about tools is there's a continual evolution. Here's Lara Croft from back when I started playing Lara Croft to the last time I played Lara Croft on this far side here. And there will continue to be an evolution of tools. When I started in the game industry on the Atari and Sega Genesis games, basically we had Deluxe Paint and Deluxe Animator that were 2D programs that we created with, and I don't think you can even buy those programs anymore. We had if you take that same acceleration that happened in those 20-some years and project 20 years out, I think the tools of today are going to be similarly outmoded over time. So that's why in teaching game development, it's important that the underlying principles are really emphasized, and that students also understand that learning one tool is not going to be their key to success, because those tools are going to be morphing and changing year to year. So let's talk a little bit about some of the tools. Concept art. Most common tools, Adobe Photoshop, Corel Painter. I've seen some Autodesk Sketchbook Pro being used. For concept art in the game industry, there's really kind of two types of concept jobs. One, like the picture on the lower left, is a mood piece that might be created to sell the idea of a game. To get the company excited about making that game. It'll be used in a lot of pre-production sites and on websites and articles. So very high-end illustrator might create these mood pieces, but probably a more common concept art job is the ones on the other side there, and these I would call kind of functional concept art. In the one you see there's some different wearable uniform designs for an orc. On the bottom, there's some different plant designs for an ecosystem. So this type of concept art is not taken to the full-blown, beautiful painting exhibit in the gallery. There's just enough functional concept art there that you can give that to a modeler and have him understand what he needs to create. And, fill in some of the little details that may not be there. So that's kind of the two ways to approach it. And all those programs are good for either type of concept art. The industry standard now is the Wacom Cintiq, or for studios that don't have the Cintiq, I see a lot of people use Intuos tablets. There is no more paper art production in game development at a game company. Everything is digital now. So, you know, someone who does a little bit of concept art might use an Intuos tablet, but I think about 100% of our concept artists were using the Cintiq style draw on the monitor. Modeling programs, you guys are probably familiar with the most common ones. Pixelogic ZBrush and Autodesk Mudbox. Both of these programs kind of came on to be industry standards in the last 7 or 8 years or so. And the user faces or user interfaces for these games are getting more and more applicable to a student just picking up and learning how to manipulate. It's like creating something with clay. So it used to be in the old days there was a lot of math and calculation involved. Now that interface is becoming much more natural, and you're using tools to push and pull and sculpt with. So you still have to be a good sculptor to make an outstanding looking 3D sculpture. But all those digital tools are much easier to understand. Now, in game development, we would hardly ever use something of this high fidelity in a game outside of like a game movie intro. So Autodesk Maya and 3ds Max are other more common 3D tools we use. Blender I put on here because I've seen a lot of students pick up Blender because it's free and it's open source. While most of these programs also have student versions available, there's a large user database for Blender and a lot of videos and a lot of user communities that give feedback, so that is a popular program. So what we typically do with our asset development path is we will sculpt high-end models, and then we will use that model to create something called a normal map, which takes that same detail, and I don't know if anybody has seen a normal map before, but basically it's a 2D map, And when it's applied to a lower polygon mesh, each of those pixels interacts with light slightly different. So it'll give that same impression of high detail. So you can see the characters are split in half. You have to see the very high detail mesh on the other side, and we'll generate a normal map from that then will project on the lower detail mesh. Because there are restrictions in how many polygons and how much texture memory we can use to deliver a product. It's not open-ended, there's a cap. So that's kind of the puzzle. It has to be designed in such a way that it's still going to fit within the allotted memory. The Wacom Cintiq is pretty much standard here too, because in sculpting it kind of imitates using tools. And I think Wacom has a display out there you guys should just definitely check out, and they could tell you a little bit more about those kind of applications. Texturing. Yes, question.
About 3DS and Maya. Are you seeing a shift that Maya is becoming more used or not?
More game companies use Maya, in my experience. Mac still has a foothold there. I've noticed that, like at Art Institute, they have both Max and Maya. So they teach both. But I think Maya tends to be used more than Max does. It's not critical, you know, and I'll talk about this a little bit later. From a student standpoint, I don't think it's critical one or the other, because both of them use very similar methodologies and teach, you know, how to interact and create something in 3D space. If you understand Max and are a very high functional Max user, in a matter of a month and a half or so, you could translate those same skills over to Maya. And I know a lot of schools probably picked one or the other. They're both under Autodesk now, so I think they're seeing more and more similarities between the two. Texturing, you know, we still do a lot of standard texturing with Photoshop, but more and more textures are being done procedurally. Prime company for that is Algorithmic's Substance Shader, which it comes with a large suite of different style substances that you can manipulate. And it has a companion program called Substance Designer, which lets you input new attributes and kind of design your own substances. And Mari by Foundry is another program that does this. The reason the industry is going this way is we have to deliver more and more content to the screen. And when you're doing bitmapped textures, those are high cost assets, where a procedural texture is a much lower cost memory asset to create. So it's definitely seeing a shift toward more procedural generated textures. On a bitmap texture, you are opening up Photoshop and you're painting like a 512 by 512 square. So when that memory is calculated, it has to know the color value of each pixel across 512 by 512 pixels. Where in a procedural generated texture, it's using mathematical calls to generate the same look. It's similar to the difference between a vector art and bitmapped art, where if you draw a circle with bitmapped art, it still has to calculate every single pixel. But if you draw a circle with Adobe Illustrator, all it needs to know is certain points on the circle and what the arc is. So on a much similar level with the textures, it's the same thing. It's using minimal computational calls to deliver something that's evocative of what you could do just with regular 2D hand painting. For rigging, Autodesk Motion Builder is the most commonly used program. What Motion Builder allows you to do, which is really cool, is you can create a set of animations for a human, and if you make a similar rig like for, I don't know, a gorilla or some other type of biped, Motion Builder will allow you to take that motion and apply it to a different proportion rig, and it will solve it. You know, once you identify which are feet and which are hands, it kind of uses those as endpoints. So like a gorilla has short legs, but it knows that the legs have to fall on the ground. So it'll do its best to solve and recalculate those animations based on a new skeleton. So we use Motion Builder a lot. Other 3D programs have similar features. You can build rigs in Maya and in 3D Max as well. But Motion Builder has the deepest suite of tools. For animation, probably about, I'd say 75% of our artists use Motion Builder for animation. The rest tended to use Maya. If you're doing 2D work, it's a little different. Toon Boom's popular. They have two products, Harmony and Storyboard Pro, that are good for making 2D games. And for effects, most games now are using the real-time in-engine effects from commercial game engines. Or like in the case of Sony, we programmers created our own proprietary effects engines that we taught the artists how to use. I'll mention Houdini here, which is another great program for effects, and is actually Houdini is a full-rounded program that you can animate and model in as well. And for user interface, Autodesk Scaleform is the program of choice for most studios, game studios I'm familiar with. Technical artists. Technical artists are writing most of their scripts now in Python. MEL, or Maya Embedded Language, used to be the primary tool probably 7 or 8 years ago. Python scripts can call MEL scripts now and understand MEL scripts. But at all the Sonys, I believe, Python is now the tool of choice for developing scripts and tools for artists. And I briefly mentioned commercial game engines. So probably the three most common ones are the Unity engine. Has everybody heard the Unity engine? That I think has the biggest buzz, and I know at Art Institute, Unity and Unreal are the two engines we tend to use at Art Institute, and Coleman uses Unity. There's the CryEngine, and Amazon Studios has a new engine called Lumberyard that they're just rolling out with their game studios. And these are really fully functional game engines that are great for students and independent developers and small companies because it comes with the whole suite of game engine programming built right into it, where you can just populate it with your content. So a lot of people ask about augmented reality and virtual reality. So the difference, augmented reality, think Pokemon Go, where the content is appearing in the regular world somewhere, or you've probably seen some of the card games, where you can lay down the card and, character comes to life off the top of the card if you're looking through your iPad. Augmented reality also has I was at the Lego store last year, and they had a little kiosk. Anybody seen that Lego kiosk where you can see what's in the package? That's kind of cool. And then, of course, virtual reality. The old Morton Hellick Sensorama from 1962, which I always thought was kind of cool, has now come full circle, and it's actually here, and you could buy and wear all kinds of fancy VR equipment. So probably 5 years ago, everybody was talking about everybody's got to do mobile. Everybody's got to do mobile. Now everybody's talking about everybody's got to do VR. Everybody's got to do VR. So the important thing I think to remember about trends like this is the programs that I mentioned can be used on mobile and they can be used on VR. So if you're making a virtual reality game, you still have to build assets, you still have to make a user interface, you still have to animate things. And the only real difference is on the programming side is how you interface with the actual 3D module. So there is definitely programming tech involved there, but as far as the art and design tech, I think everybody's fine just, sticking with these traditional tools because they're the same tools being used in the VR industry. So, career pathway opportunities. One thing that I've noticed in the last decade or so is the evolution of the gaming communities and how that has really spawned a large group of aspiring game developers. And you can see that demand being echoed in college and high school programs that are now wanting to get into tapping into this need and enthusiasm for, hey, I want to be a game maker someday. So how did we get there? Gaming is about communities now. Years ago it was about playing by yourself or playing at the arcade with some people watching over your shoulder, or you played at home. Online changed all that. I think when you get down to the root of it, gaming communities, it's a social experience with a game wrapper. So people are people become as attached to the social experience they're having with their friends as to whatever the game is that they're playing. So, and these communities have now kind of self-organized, whether it's a small group of friends or larger groups that can communicate over the internet with gaming guilds, where people join forums and they talk about what they're playing this week and what's coming out and who's going to play this game next, and getting together and organizing what they're going to play and when. It's multi-generational. I saw this a lot in the MMO industry, where we had our fan conventions every year, and we would get to meet the people that were playing the game titles we're making, and each server where people played, they had different tables for servers and different guilds or groups that they were part of, and you could go to a table and you could see two high school kids sitting next to a grandmother, sitting next to a military vet, sitting next to somebody else, and multi-generational and multi-interest, kind of all coming together to experience the game world, which was pretty cool. Where 10 years ago you would see groups that were dedicated to one particular game, now those groups are kind of transitory and they will move from game to game. So you see a lot of online guilds that decide, hey, what are we going to play next month? This game's coming out. They all rush in and play that game, all rush in and play another game. So the communities that have grown outside the games kind of become their own animal. And that community relationship has changed with developers. So everybody's familiar with Twitch. Twitch is, if you go to Twitch, it's a streaming content site where people record themselves playing games or doing a podcast or about a video blog about what they're playing. So that's led into esports, and it's really sort of been jarring and different to me because I didn't grow up with that type of thing. But half the time I see my kids doing stuff with games, they're watching other people play, and half the time they're playing themselves. So Twitch is another part of this glue that has created these large gaming communities. And esports, is everybody familiar with esports? There's colleges now, I think there's 2 or 3 colleges in the US that have esports scholarships. So, and you know, for League of Legends, they fill up stadiums with people watching the best players play these games. So all this sort of passion is what kids are growing up with, and is part of what's getting them excited about not only participating as a gamer, but as a broadcaster, of a commentator, and getting in and actually kind of building these kind of assets themselves, and either starting their own companies or little indie games, or trying to build a career so they can create this kind of content that they love. So a direct outgrowth of this that I saw when I was at Sony was Player Studio, which was patterned after the Steam Workshop. Both of these programs allow people outside the game development team to design items for the game. I'll tell you a little bit about Player Studio because that's the one I was involved in developing. We would publish a list of the technical specs, and we also had a style guide for items, and players could design their own items for the game. I think for EverQuest and EverQuest 2, you could design weapons or armor, capes, and objects, or little small objects you could put in your player house. And so people would create these objects in a 3D program. If it made sure it fit all the technical specifications, they would submit them via an online form to the studio. It went to the game team. We vetted those assets, and if any of the assets were good enough to go in game, they got put in the game marketplace where players could buy those assets, and then the creator got 40% of the revenue from the sale of that asset. So this was a great way for a game to actually get assets created outside the game studio, but it was even a better way to get people excited about continuing to play that game. Because if you created something for it, you're more likely going to keep playing it and tell your friends, hey, go buy this thing, it's really cool, I made it, it's actually in the game. So, and this kind of user-generated content, I think, directly relates to what's aspiring game developers for game jams. Is everybody familiar with game jams and global game jams? We just had one at Coleman in January. It's usually and we had a number of high school students there, mostly college, but I think we had like 10 or 12 high school students at the last game jam. So they'll have local game jams. They're usually 48 hours long. The only difference in a global game jam is it's simultaneously held in locations all over the world. So in the last global game jam, each game jam started off with revealing what the theme was. So for this last January, the theme was waves. So participants would show up either with people they wanted to make a game with, or they just show up and say, let me join a team, this is what I can do. And in 48 hours, they had to make a game that had something to do with the concept of waves. And when that game was complete, they would put it up on the Game Jam site, and then other people would comment on it or download it and play it. So this is a great activity for, I'd love to see more high school students do it. A lot of college students do that. They really look forward to the Game Jam. So it's like staying up 48 hours straight. They don't, well, some of them sleep a little bit, but. So the only bad thing is, like when I'm at Coleman, is having to do the night shift on the Game Jam. That's not as fun. And indie development, everybody's probably familiar with Steam, which is a portal where you can download, buy AAA games and small independent games. There's a couple other ones like Game Jolt that do the same thing. Steam has a green light process, so a small group of developers can make a game, put it on the green light site, and if enough people upvote it that they would be interested in buying it, it can be sold on Steam. So this is another viable way that didn't exist 15 years ago for people to make games. I mean, it used to be, unless you were making a game for Sega or Sony or Nintendo, you weren't making a game. Now there's tons and tons of outlets to self-publish. So I just want to spend a minute talking about what I did as a developer, working with Art Institute and other colleges, and how we mentored new developers. So when I was at Sony Online, I created a college professional partnership. Yes.
The last slide that you had, how people are able to kind of like get their stuff out like on Steam and stuff like that.
Yeah.
I wanted to Jamie say this a couple weeks ago, and Microsoft had just announced the Xbox Live Creators Program, which opens it up. It goes alongside their ID at Xbox, but it opens up for everybody now to develop games for Xbox One and Windows 10 without having to go through their certification process.
Oh, that's great.
Pretty cool.
Yeah, so it's...
So you can turn retail Xbox One units into dev kits that they can
Oh, very cool.
create their games.
Very cool. So it's exciting to see that amount of co-op between developers and game developers and game players, and I think it's all part of creating that that synergy between what's a player, what's a developer, what's a and it definitely in a program like that it builds loyalty to that console too, if you're able to essentially have a dev kit, which you could only get in the past by being a certified developer. So that's really neat. So when I was at Sony Online, one of the things the challenges that I had in charge of the art department there was bringing on new talent. With massively multiplayer online games, we had games that were live games that had continual users that we had to make new content for, and we had brand new games we were starting. So one of the challenges was attracting people to the existing games, because people that worked at the company, a lot of them wanted to be on whatever the next cutting edge thing was. So it was a great place to bring in new talent. So I created a professional mentoring partnership with Art Institute of California, San Diego, and they created a prototype and advanced prototype class. So it was 22 weeks long, 2 sets of 11 weeks, and got permission from our legal department to assign the class one of the intellectual properties from SOE or Daybreak Games. So they would be assigned like EverQuest or PlanetSide 2, and their job in this game prototype class was to create a zone and some non-player characters that would fit in with one of our existing games. Now, they were free to create whatever they wanted as long as it hit the quality bar. So they had a quality bar they were comparing themselves to, and they were also not starting from scratch. It was like you're getting a real job. This is the game you're working on. You can be creative, but it still has to kind of fit in that universe. And so they would work on those games for 22 weeks. And we would go visit and act as like an outside producer. So every 2 weeks we would go to the class for an hour and the instructor would have them come up and they'd show our progress, and we would give them feedback, and we were really hard on them, and we made a few of them cry, but it was okay because it was a better product at the end. And although one of the stipulations was we wouldn't use any of these assets because you didn't want to cross the line of like having students create things for a game without compensation. So all these projects were just for kind of for exhibition only. But if their product hit a certain quality bar, we would let them present that final product at the company, meet the development team. So it was a great way for them to have pride in what they did, show it to the other developers, and actually make some business contacts. And what we had that grew out of that was an internship system. And a lot of the students that came through that program and did a great job with that student-based, student professional mentoring were some of the prime internships that we ended up getting. The other Sony entity, they call it SCEA, they just changed their name to SIE now. But they have a large suite of internships they have open all the time. So that's a great place to check out for students looking for internships is locally Sony. So something that I've observed in the last decade or so is the evolution of the expected competencies. Of course, it was very different when I got started in the game industry, but even a decade ago, it was still very common for us to hire people that were just generally familiar with 3D programs and do a lot of teaching and mentoring on the job. That pretty much is not the case anymore. Graduates that are getting entry-level jobs in the game industry already come with some team game development experience, either at college or on their own participating in game jams. They'll show us, hey, here's a game I put together with some friends. They've had an internship, and they have software expertise. So even if that software is not the exact software we use in game development, that coming in with that expertise is important. I think generally at the college level, we've been doing a pretty good job in prepping students to have those competencies to be a prime candidate to get an entry-level position. And then backing that up to high school, what I see now that I'm with the Art Institute, students coming from high school into the Art Institute is we need students to be software competent, and generally students that are coming from high school have either in high school or on their own dabbled a little bit in the 3D software and 2D software.
Yes, would the content developers fall into that same category of needing some technical background, or is that, how's that?
Designer, content developers?
Content designers, yeah, I mean, you can develop a story and dialogue, are they often adept with the other technical?
Yeah, most of them that are coming in, although we get a lot that initially would get placed in testing and then move on over. They've had those same experience in team game development and doing game jams and things like that. Or this is a game I designed, and I did some of the art for it, but it's my design. But yeah, for sure. That, and often content developers will show us non-digital game design as well. This is a card game I came up with, or a board game I designed, and here's the rule sets. Yes, I'm going to go into that. I'm going to go into that in a second. So what I see coming into the Art Institute, generally software competent students. So they come in decently. They need to have the fundamentals because it's just beginning fundamentals at college and getting all that technical training is a pretty tall order. And that is probably one of the shortcomings I've noticed at Art Institute. Is it's kind of a flip of what I saw years ago. Is people would come in with stronger fundamentals but not very technically savvy. Now I see more people coming to the Art Institute with some technical savvy but really poor art fundamentals or next to no art fundamentals. And that really affects the quality of what they can produce.
You're talking more like elements of art, principles of design.
Yeah. English skills, writing, being able to write a coherent paragraph or tell a story. Yes, understanding how light hits an object, what's reflected light, perspective, things like that. Yeah. So preparing students, and that's what I want to talk about briefly here. What I think, just from my perspective, that is really needed in the students I'm seeing coming to the college level is stressing those fundamentals. And the digital content creation in 2 and 3D should still, I think, be focused on fundamentals, understanding how shapes are constructed. And here's an example. I mean, if this is your level of how you can draw a hand, that's your level of how you're going to model a hand, right? It's not magic, But, I mean, if you can, okay, this is Bern Hogarth. Okay, it's not a student, but if you are Bern Hogarth level of drawing a hand, you're probably going to model a better hand than if you're this level of drawing a hand. So, and a lot of times I think people get too carried away with the software and skip the fundamentals. Students do. So I like to have students work on a sketchbook in my classes too, even though they're digital classes. I like to see stuff they're observing and sketching because that I think is kind of becoming lost in the digital age. You're only going to be good, and it's the same thing with English as if you're a game designer or you want to be a content designer. If the sum total of your knowledge is movies and Blu-rays since the year 2000, you don't have a big wellspring of mulch to grow your content out of. So the more knowledge you have, the more creative you can be. So stressing art fundamentals, computer science, game design of both the digital and non-digital. A lot of the foundational design principles can be taught without doing a actual computer design. And math and English. Broad versus specialized. I tell students this in college. I think it's applicable in high school as well. Unless you're really passionate about a one particular specialty, it's better to stay broad because you have no idea what opportunities are going to be out there, and if you focus too narrowly in on one thing, you may miss dabbling in a bigger picture. Extracurricular in high school, job shadowing, which I'm sure a lot of folks have done, game jams. Encourage them to join the International Game Developers Association. There's a chapter here in San Diego. I think we're running short on time. Yeah. We're out of time? Yeah. How much are we over? Yikes. Okay, well, let me just do the last slide here. I always like to say the key things about longevity in the business is becoming valuable and staying relevant. Understanding that you're going to work at a lot of different game companies. It's not years ago, you work at one company for 40 years. There's a lot of contracting and outsource opportunities available for as careers as well. And two other things that I wanted to mention. This is a challenge in college, and I'm sure it is in high school as well. We ask students to be really passionate about their work, but we also ask them to be detached enough that if something changes, they can give it up and move on to something else. So be passionate about the project and what you're doing, but understand the project's always bigger than what your little particular piece. And if there's one particular thing I think we can equip students with, high school and college, to go into the game development, is learning the ability to critique themselves. If you can look at your own work and figure out there's something wrong with it, you're 90% there to being successful at what you're doing. If you look at your work and you think it's the greatest thing ever, then you probably have some problems. So that if you can learn to self-critique, that's key. And a couple quick recommendations: Theory of Fun, Ralph Koster, Game Design Workshop, and the Challenges book. And I'll leave that up there. And sorry we're over time. I didn't know it would take that long. Any questions? All right. Well, thanks. It was a pleasure talking to you.